Welcome to the second part of this video tutorial. So we will begin with the last result. So this is a risk map, or maybe the risk layer. And first of all, I would like to say to you that all calculations you are doing here are just temporal. So if we look at the properties of this layer and also the source, you can see that it's it's storaged in the temp folder of your PC, and if you would like to make it like a file of it, like a TIFF file, you have to press the right button and say data, export data, and in the end you can say, okay, this the extent is the original extent and not only the current extent we can see here in the frame, and also the spatial reference is the original reference, which means that you have the UTM zone, and we can choose location. Okay, the folder should be maybe a new folder, risk management, and we will use that folder. And okay, one moment, there we go. And also we are more interested in TIFF files, and we say, okay, risk basic. This is the name of the file. So we will save it. It goes quite quickly, and you can see here there's a original layer. Here's a new layer. You will find the file type in the end, .tiff, and so we will just remove the old layer. So there's no difference between these two informations. And let us suppose we are interested maybe in the size of the areas which have highest probabilities of being treated by rockfalls. So we can just see the attribute table, and here you have one information, that is the count. That means how much pixel have the value of 3. It's about 18,000, I think, and so you can multiply it with the cell size and you get a first information of the size. But there's maybe one problem. In the end, maybe you're interested in adding some kind of variables to that layer. So like size, we already know that layer, but also maybe is it in the near of some kind of anthropogenic feature like streets, villages, or whatever, and also every information you would like to add, maybe also some pictures of that kind of area or whatever. So therefore we will convert this layer, this raster layer, to a polygon. We will just double click raster to polygon. You can find it in conversion tools from raster, as we are going from raster to a polygon, and we'll say, okay, the input raster is risk basic. Take some time, and the field optional is not count. So then the shapefile you will create will have the number that is written down in counts added to the shapefile. But we are interested in values, so we will differ between 0, 1, 2, and 3. And let us give a name. So it's /risk.shp, and so we will just uncheck simplified polygons. If you check it, then the polygons will be smoothed into simpler shapes. But as we are going from a raster to a polygon, we are interested in more normal view and not in a smoothed information. So this will just change the information, and that's not so good. Okay, we will just click it. As you can see, it's converting to shapes. Actually, these are about 200,000 polygons, so it takes some time to add the outputs to the map, as just using a normal PC here. So maybe you can go out, take a coffee from the kitchen or whatever, and sing some nice songs. So there we are back again. So you have the polygons of the risk.basic file, and you can see here that all the pixels are now in shape, so we don't have any triangles or whatever. But you have one major problem here. So if you're having a look to the attribute file, you can see each area of pixels, like this one, as one certain polygon, and therefore you have a lot of features, like here 190 thousandths. and we would like to merge these polygons regarding to their grid code, so that you only have one polygon with the grid code 1, one polygon with the grid code 0. Therefore, you're going to options and select by attributes, and they can make a simple SQL statement like, give me all polygons with grid code is the same as 0. So this checks all the files here, or all the polygons, whether the grid code is 0 or not. We will apply that, and as you can see here, you can scroll through, every 0 entry is checked. And in the end, we would like to start an editing session with that layer. So we're going to the risk management folder. There you have the risk polygon shapefile. Okay. And now what we can do now is, we could obviously sketch some new things, but this layer is completely okay for us. So we'll just merge these classes. So you go to editor, merge, and this will merge all the selected features in the attribute table. So we will just click OK. As you can see, it's still working. So here we are back again, and you can see here that we have only 184,000 files, or polygons in that case, and we will just do that again for every grid code of these. So we'll just do it again for you, and afterwards I will just import the new file. So select by attributes again, grid code is not 0 anymore, maybe we will do it now with the third. Apply, and these are 12,800 polygons. Close that one, editor, merge, and just click OK. In that short list you have seen there, you can change the value or the polygon you would like to use as a main polygon in the end. So we are going through that. Also, the number of polygons has decreased or is decreased, and you will do that for every kind of grid code. So 1 and 2 still missing. And in the end, just do not forget to data export, as you have just changed that shapefile, and before that you have to save your edits. So we have just saved the edits, and now we are stopping the editing session. Make this a permanent layer, data export, and you have risk.shape or risk b.shape, and okay, exporting risk feature class. This will take several seconds, especially if you have just make it like I've done it, with only a few features merged. So now let us assume that you have all done this. So you have merged all kind of polygons. We'll just show you the result of it. So this should be some kind of new polygon file. It's called bereinigt in my case. And what is obvious, if you're opening the attribute table, you will only have 4 polygons, each with the normal grid code like 3, 1, 2, and 0. And now we are interested in calculating the size of it, and therefore we will search for a tool that is calculate area. There we have the calculate areas, and therefore you will need an input feature class. That surely is bereinigt in that case, and it will create an output feature class. The output feature class will look the same in size, but you will have a new variable available in that layer, that is the variable of the area. So we check another folder, risk management, risk.srp underscore areas. Okay, you can see it here, writing results to the output feature class. This is completed. I've just unchecked it because it takes so much time. And if you're looking in the open attribute table, there you see the amount of area each class has in square meters. So you have to maybe recalculate that to square kilometers, but that's for it. And yeah, thanks for watching.